Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the fascinating world of Inco's borrow checker, or rather, the inevitability of its borrow checker, as explored in a recent article. The core issue? Balancing the speed and efficiency of stack allocation with the safety and flexibility of heap allocation. It's a classic trade-off, isn't it?
Absolutely. And Inco, with its unique approach to single ownership and move semantics, makes this challenge even more interesting. So how does Inco currently handle this? Heap allocation by default, I presume?
Precisely. By default, types in Inco are heap allocated. This offers great flexibility, allowing values to be moved around even while borrowed. The mechanism uses reference counting. Each heap type tracks its borrow count. A zero count before dropping is fine, but anything else triggers a runtime panic. Uncatchable, mind you.
Right, the classic reference counting approach. But that heap allocation comes with overhead, right? Pointer chasing, memory usage. The whole shebang.
Exactly. The overhead isn't just the allocation itself. It's the pointer chasing, the reduced optimization potential compared to stack allocation, and the extra memory needed for the borrow counter and method table. At least 16 bytes per heap type. That's where the inline modifier comes in.
Ah, yes, inline types. So these are stack allocated? How does that change the borrowing game?
Yes, inline types are stack allocated. The interesting part is how borrowing works with them. Instead of managing a borrow count, when you borrow an inline type, it's copied. If it contains heap allocated fields, those are borrowed individually. This cleverly maintains borrow validity without the overhead of reference counting for the entire inline type.
That's a neat trick. So, it's a copy-on-borrow strategy for inline types. But what about the limitations? The article mentions some.
Indeed. There are two main limitations. First, if an inline type has many heap-allocated fields, borrowing it requires many individual borrow increments, negating some of the performance benefits. Second, and more significantly, you can't assign new values to fields of inline types. This prevents subtle, hard-to-debug issues related to aliases and inconsistent views of the data.
I see. So the immutability of inline-type fields is a deliberate design choice to maintain consistency and avoid unexpected behavior with aliases. But that limitation restricts the use cases for inline types, doesn't it? Iterators, for example, often need mutable fields.
Precisely. That's the crux of the problem. The author explores several potential solutions, allowing field assignments with a copy-on-move scheme, introducing unique types, escape analysis, and finally, compile-time borrow checking. Each has its own set of challenges.
Let's briefly touch upon those. Allowing field assignments seems fraught with complexity, potentially requiring runtime checks and a complicated copy-on-move mechanism. Next. Unique types, while elegant in concept, seem to introduce significant complications with composition and closures.
You're spot on. Escape analysis, while appealing in its potential to automatically optimize heap allocations, is likely to be too conservative to provide significant benefits in practice. The author concludes that compile-time borrow checking, similar to Rust or Austral, might be the most robust solution, but also the most complex to implement.
So a classic dilemma, simplicity versus power. It seems Inco faces a difficult choice. The author suggests that a borrow checker is inevitable, but the implementation details remain a significant challenge.
Exactly. The article concludes with a sense of thoughtful uncertainty, highlighting the trade-offs involved and the ongoing exploration of different approaches. It's a fascinating look into the design choices and challenges faced when building a language with strong memory safety guarantees. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of Inco's borrow checker. Goodbye.
Bye-bye.